Hello and welcome to another edition of the Integrated Science Intervention Program. This is the last in the series of electronics. Today we look at transistors. My name is Kisiwa Edu. For our starter, we introduce ourselves to transistors. From our previous lesson, we got to know that when you put a p-type and an n-type together, you form a diode. In this lesson, we are going to put a p-type, an n-type, and another p-type together to form a PNP transistor. Alternatively, we can put an n-type, a p-type, and another n-type together to form an NPN transistor. We would look more into details what transistors do as the lesson progresses. In today's lesson, we are learning to describe the structure of a transistor, and then we'll investigate the uses of transistors. We will begin by describing transistors, then we will demonstrate transistor applications. The key words we would encounter in our lesson today are transistor, emitter, collector, base, amplifier, and switch. Do you know what transistors are? Well, transistors are 3-pin electronic components that are used to amplify and switch electronic signals and power. These are some examples of transistors. Types of transistors. There are two main types of transistors, namely the bipolar junction or the BJT transistor and the field effect or FET transistor. For the purpose of today's lesson, we'll be looking at the bipolar junction transistor. The bipolar junction transistor is a transistor that is produced by combining two junction diodes. The first can be a thin layer of a p-type sandwiched between two n-type semiconductors. That is the NPN junction transistor. Or a thin layer of n-type sandwiched between two p-types. That is the PNP bipolar junction transistor. The name bipolar simply means two polarities, a positive and a negative. This is how the NPN transistor looks like in a circuit. And that is how the PNP transistor looks like in a circuit. Now let's look at the structure of the bipolar junction transistors. In the bipolar junction transistors, there is a thin middle layer we call the base. The base controls the flow of charges. The other two layers have varying sizes. The smaller of the two outer layers is the emitter. The emitter supplies free charges, while the second outer layer is called the collector. The collector collects charges from the emitter. Now, let's investigate the applications of the bipolar junction transistor. But before we do, we would want to have a look at this video that explains how transistors work.
We know that if we connect a light bulb to a battery, it will illuminate. We can install a switch into the circuit and control the light by interrupting the power supply. But this requires a human to manually control the switch. So how can we automate this? For that, we use a transistor. This transistor is blocking the flow of current, so the light is off. But if we provide a small voltage to the base pin in the middle, it causes the transistor to start allowing current to flow in the main circuit. So the light turns on. We can then place a switch on the controlling pin to operate it remotely, or we can place a sensor on this to automate the control. Typically, we need to apply at least 0.6 to 0.7 volts to the base pin for the transistor to turn on.
Welcome back. Now let's head to our electronic workroom to investigate the applications of a transistor, first as a switch, and later on we will see the transistor as an amplifier. Welcome to our electronic workstation again. In this demonstration, we would use a battery, a resistor, a transistor, LED, and some connecting wires. In this demonstration, we want to show how the transistor behaves as a switch. To do that, we are using a BC547 transistor. Now, to identify the pins of a transistor, you need to search for the manufacturer's data sheet. So you just key in the number on your transistor on a Google search and you would get the pins of your transistor. So for the transistor we are using, this pin is the emitter. The pin in the middle is the base and the last end is the collector. So from our circuit, we put our transistor on the breadboard. The base of the transistor is connected to a wire. We are going to leave that wire hanging for now. The emitter is connected to the negative side of the battery. The base is connected to the collector is connected to the negative side of the LED. And as we've studied, the LED needs to be protected, so we are going to connect the positive side of the LED to 1000 ohm resistor. The other end of the resistor goes to the positive side of the battery. One end of the resistor is also in series with a wire. Now we have completed our circuit. For the transistor to switch on, it needs a little voltage at the base emitter region. When we put the two wires together, the LED comes on, but it doesn't stay on for long and the brightness is very low. Now let's see whether we can create the needed voltage needed for the transistor to switch on. So I'm going to rub my hands with some water and then I will touch both ends of the wire. So this has provided the needed voltage for the transistor to switch on, and so the light comes on. In this way, the transistor behaves as a switch. And this circuit could also be used as a water level indicator. So now that we are done with the transistor as a switch, we want to move on to the transistor as an amplifier. For that, we still need our transistor, a couple of resistors, and we will introduce a new component. The LDR, light dependent resistor. So for our amplifier circuit, the base of the transistor goes to 100 ohm resistor. And then we will connect the LDR and another resistor in series. One end of the resistor goes into the middle of the series arrangement of the resistor and the light dependent resistor. One end of the resistor in series with the light dependent resistor goes to the positive side of the LED. It goes to the positive side of the battery. The other end of the LDR goes to the negative. So that one together with the collector go to the negative. Sorry, together with the emitter goes to the negative. Now the collector is connected to the negative end of the light emitting diode, and that is also connected to a resistor to protect it. Now I need to put this resistor in that resistor so that they all are connected to the positive side of the battery. Now the negative side, the resistor I used earlier had a high resistance, so we are changing it with a lower resistance to complete the circuit. Now this resistor is in series with a light dependent resistor. So we fix our positive terminal of the battery and our circuit is complete. Now the current that is produced at the emitter base junction is amplified at the base collector junction. So we see that our LED is bright. This is how the transistor functions as an amplifier. We would summarize the transistor application as an amplifier in the video that follows.
Replace this representative transistor with a realistic one. You can further improve the amplification by introducing one more transistor. The base of this transistor is connected with the emitter of the first transistor. If you introduce a weak fluctuating signal at the input, like what you would find in a microphone, you will get an amplified signal at the loudspeaker.
Welcome back. It's been an interesting lesson. In this lesson, we have learned to describe transistors. We have investigated the application of transistors. For our task, draw the circuit symbol for an NPN transistor showing the following: the emitter, collector, and the base. Thanks so much for your attention, and we'll meet again in another video. Bye bye.